Hi my dear students. So this video is watched with earphones because it is clear to listen. That's why. So by using the earphone, watch this video. Hi my dear students. So in the last session we are discussing the number of atoms present in a unit cell. It may be simple cubic unit cell, or a body centered cubic unit cell, or a face centered cubic unit cell, or a edge centered cubic unit cell. So based upon this one, now we are going to discussing the problems. So the problem number 1, cubic unit cell. A cubic unit cell is made up of 3 elements. Cubic unit cell is made up of 3 elements, X, Y and Z. So elements are X, Y and Z. Right? The atoms of X are present at the corners. Atoms of X are present at the corners. For example, this is the unit cell. So these are the points. So in this points, this is the unit cell. So atoms of X are present at a corners. So whatever the corner points are present are lattice points. So these lattice points are X atoms. Lattice points are X atoms. And atoms of Y at the cube center. Y at a cube center. And atoms of Z at the center of each face. So this crystal lattice containing corner particles, body centered particles as well as a face centered particles. So corner particles is indicated by the X, body centered particle is indicated by the Y, and face centered particle is indicated by the Z. So atoms of Z at the center of each face. What is the formula of the compound? So now we are going to calculate the formula of the compound. So solution, the number of atoms, the number of atoms of X per unit cell. So number of atoms of X per unit cell. So in this one, X per unit cell means you know that the X present at the corners means 8 corner particles are present. Number of atoms, 8 corner atoms are present. So this is the corner particle. Taking this one is a corner particle, and into the contribution of corner particle is 1 by 8. So 1 by 8 contribution. So therefore 8 into 8 1. Number of atoms X per unit cell is 1. And same number of atoms Y per unit cell. So is equals to, so Y at the cube center means a body centered particle is containing the only one at the center, and its contribution is also 1. So its contribution is also 1. Therefore 1 into 1 1. Clear? And the third one, number of atoms Z per unit cell is equals to number of atoms Z per unit cell is equals to at the center of each face. At the center means how many faces are present? 6 faces, and this is the 6 atoms are present. In this 6 faces, the contribution of this one is, so this is the 6 faces, and its contribution is 1 by 2. contribution is 1 by 2. Therefore 6 2 1s are 2 3s are. Therefore 3. The formula for this compound is formula of this compound is X Y, so therefore Z3, X Y Z3. So this is the formula of the XYZ compound. XYZ compound. Clear, my dear students? Then problem number 2. A cubic unit cell consists of 2 elements. So cubic unit cell consists of 2 elements, P and Q. P and Q elements. P and Q atoms of P are present both at corners and face centers. So P atoms present both corner and face center particles. So in the cubic unit cell or in crystal lattice, there are 2 atoms. One is the P atoms and another one is the Q atoms. So this crystal lattice or a cubic lattice having a body centered as well as a corner particles present in a unit cell. So P is present at the corner particle. These are the corner particles. So P particle. Along with this one, a face centered particle is also P. So next one, present both at corners and face centers, while Q are present at edge centers and body centers. So Q, the particle Q is present edge center and body center inside the crystal, body center. So edge center is a particle, that particle is a Q particle, and inside the body containing the atoms, that is the Q atoms. So what is the formula of this compound? So solution, the crystal lattice containing the 2 atoms P and Q. The P is atoms are present corner as well as a face centered particle. Q atoms are present edge centered as well as a body centered particle. So the number of atoms of P per unit cell is equal to first one corner particle. So corner particle 8 corner points are present into its contribution is 1 by 8. Its contribution. So this is the contribution part. Its contribution. So along with this one, the P atoms also present at the face centers. So face centers, how many places are there? 6 places. And its contribution 1 by 2 contribution. So 50% shared with the one unit cell and 50% shared with the another unit cell. So therefore, so this is the 8, 8, 1 and 3. Therefore 4. So unit cell containing the 4 P atoms. And the second one, number of atoms. Number of atoms of Q per unit cell. Is equal to, so this is contained in the edge center. The unit cell or crystal having the edge center, how many edges are present? Therefore 12 edges. So in this 12 edges, its contribution is 1 by 4. This is the contribution. So 25% of the unit cell shared with the other 3 unit cells. 1 by 4 plus, and along edge center along with the body center, so there is only one particle present inside the cube, and its contribution is also 1. Therefore 4 1s are 4 3s are 3 plus 1 is equal to 4. Therefore the ratio of atoms P and Q is 4:4 or 1:1. Therefore, the formula of the compound is formula PQ. PQ. Clear, my dear students? So these are the important problems. So these questions arises in your competitive exams or entrance point of view. Calculate the formula of the compound. X and Y atoms are present, or P and Q atoms are present. One is a BCC and FCC are a simple cubic. So based upon these problems, many problems we can solve. Okay. Next one, calculation of density of unit cell. So in the density of unit cell calculation, edge length of a unit cell, edge length. So you know that the unit cell, discussion of unit cell. So this is the unit cell. Unit cell. These are the particles, constituent particles. So these constituent particles are joined to form a lattice. So the edge length is, let us take an edge length is A. Edge length of a unit cell X, Y, Z. So this X, Y, Z edge length are A. This edge length of a unit cell can be studied by X-ray diffraction. So edge length is studied by X-ray diffractions. X-ray diffractions. So in the X-ray diffractions, so edge length is taken as a edge length is taken as a edge length of a unit cell is taken as a. So value of unit cell is volume is considered A cube. Volume of unit cell is considered A cube. Volume of unit cell is, the edge length is A and volume of unit cell is A. So these values are taken from the X-ray diffractions by different varying studying the X-ray diffractions of crystal lattice. So A cube value means the edge length. These are the given data. And the number of atoms of unit cell is indicated by Z. Number of atoms of unit cell is indicated by Z. Therefore, now we are going to calculate density of unit cell. Density of a unit cell is equals to mass of a unit cell divided by volume. So mass divided by volume. You know that density D is equals to mass divided by volume. Density D is equals to mass divided by volume. So in the same unit cell, by taking the unit cell, density of a unit cell is equals to mass of unit cell divided by volume of unit cell. So in the mass of unit cell, the number of atoms Z into M. So this is the Z into small letter M whole divided by volume of the unit cell is taken as a cube, whole divided by A cube. So number of atoms into mass of a unit cell. So this value is taken as a molar mass. Molar mass is equals to M mass of each atom divided by Avogadro's number is equals to mass of each atom is taken as a M divided by Avogadro's number is Na. So So this value is means a capital letter M is equal to small letter m whole divided by Na, Avogadro's number. Na means Avogadro's number of atoms present in a initial. Therefore, substituting m divided by Na is equal to m value in this one. Therefore, density is equal to D is equal to Z into m whole divided by Aq. So this is taken as a D is equal to Z into capital M divided by Na into Aq. Na into Aq. So this is the final equation for calculating the density of a initial. Density of a initial, D is equal to Z into molar mass of the initial mass of the atoms divided by Avogadro's number into value of the initial. Avogadro's number into value of initial. Therefore, D is equal to Z into M divided by Na into Aq. Na into Aq. So, unit of density. First one, the number of atoms means Z value. So, in case of number of atoms, so D is equal to Z into M divided by Na into Aq. So, unit of A is centimeter. Unit of A is centimeter, and Na is Avogadro's number. It is measured in terms of mole per mole, and D is measured in terms of gram per mole, and molar mass, and Z is the number of atoms present in a crystal letters. So in the formula units for ionic compounds, like NaCl, zinc sulfide is 4, but cesium chloride is 1. So formula units for ionic compounds NaCl and zinc sulfide is 4, but cesium chloride is 1. So next one, we are discussing the problems based upon this equation. D is equal to Z into M divided by Na into Aq. Calculation of density. So this is the very important formula. So this formula for your board examination, this question will arise 2 marks questions in an annual question paper. So remember this formula, very easy. Density D is equal to Z into capital M molar mass divided by Avogadro's number into value Aq. Avogadro's number into Aq. So for formula writing 1 marks, and for the final answer, correct answer with a unit 1 marks. Therefore 2 marks question arises in your board exam. So remember, this is a very important formula. Clear? So problems based upon density. In this problem, silver forms FCC lattice. Solution. So silver forms FCC lattice. FCC, face centered cubic initial. By X-ray studies of its crystal, so that edge length of its initial is 408A. Edge length is indicated by, so edge length X length is indicated by A. A value is 408.6 picometer. So the X length is in terms of picometer. So this picometer is converted into centimeter. So centimeter, by converting this one 408.6 into 10 raised to minus 10 centimeter. So 1 picometer, 1 centimeter is equals to 1 centimeter is equals to into 10 raised to minus 10 picometer. So this is the X length, A value is, and calculate the density of the silver. So atomic mass is M. M value is how much? Capital M. Molar mass M is equals to 107 gram per mole. So silver forms FCC crystal lattice. In FCC, number of atoms number of atoms per unit cell of FCC, how much? Number of atoms per unit cell of FCC, how much? So one is 8 corner points and the contribution is 1 by 8, 1 particle, plus there are 6 spaces and contribution is 1 by 2, 3. 1 plus 3, 4. 1 plus 3, 4. So number of atoms per unit cell in FCC is 4 atoms. So what is the formula for this one? Formula density is equals to, or D is equals to Z into capital M divided by NA into A cube. So the NA is the Avogadro's number. So Avogadro's number NA, Avogadro's number NA is 6.022 into 10 raised to 23 per mole. So Avogadro's number NA is equals to 6.022 into 10 raised to 23 per mole. So this much number of atoms present in a FCC initial of a silver crystal. So substituting this value, what is the Z value? The Z value is 4. Therefore Z is equals to 4. Number of atoms per unit cell 4 into what is the molar mass? Molar mass is 107.0 and whole divided by Avogadro's number is 6.022 into 10 raised to 23 into whole into, then what is that? A cube. A is 408.6 whole into 408.6 into 10 raised to minus 10 centimeter. So this is in terms of cube, A cube, in terms of cube, and by calculating these values, so finally you will get a 10.5 gram per cm2. So density value is centimeter per cube. D is equals to 10.5 centimeter gram per cm2. This is the final value. Clear? So this is the important 2 marks question arises in your annual examination, and for the point of entrance examination they will ask the values of density. Directly they will ask the values of density. So that is the given value. X length is given value and the number of atoms is calculated based upon the simple cubic unit cell, body centered cubic unit cell, face centered cubic unit cell, or edge centered cubic unit cells. So and another one is the molar mass is also given value, and Avogadro's number, that is the constant value or fixed value. Clear, students? Problem number 2. An element having BCC structure. The solution. an element having BCC structure, body centered cubic lattice, with a edge length of 288 picometer. So BCC, what is the edge length? Edge length A is equal to 288 picometer. So this picometer is converted into centimeter. 288 into 10 raised to minus 10 per centimeter. 10 raised to minus 10 per. Sorry, this 288 picometer. 288 into 10 raised to minus 10 only centimeter. So next one. Then the density of the element is 7.2 gram per cm cube. So density D is equal to 7.2 gram per cm cube. How many atoms are present in 208 gram of the element? So the calculation part is in BCC. In BCC, the number of atoms. In BCC, number of atoms per unit cell means Z value is equal to 2. 8 corner particles into contribution is 1 by 8 plus 1 is center of the cube. Therefore, 1 plus 1 is 2. There are 2 atoms. Z value is 2. Z equals to 2. D is equals to 7.2. A is 288 into 10 raised to minus 10 centimeter. And Na is Avogadro's number 6.022 into 10 raised to 23 per mole. Only calculating part is M value. Calculation part is M value. Molar mass. How much atoms are present in this much of molar mass? 208 gram. So the calculation density D is equal to Z into M divided by Na into AQ. So now we are going to calculate the D value, this M value. So M value and bring this Na Avogadro's number as well as a AQ. We bring into this side. Therefore, capital M is equal to D into Na into AQ whole divided by Z, and substituting the values of D. So what is the D value? 7.2 into Na 6.022 into 10 raised to 23, and next one is A value 288 into 288 into 10 raised to minus 10. So this is the AQ. In terms of AQ whole divided by. So what is the Z value? Z is equal to 2. The number of atoms present in a BCC unit cell is 2. Therefore, the molar mass is M is equal to 51.7 gram per mole. 51.7 gram per mole. So this is the M value. By substituting all these values in the above equation, so finally you will get the answer is 51.7 atoms are present in 208 gram of element. 208 gram of element. Clear, students? So these are the very important problems. These problems 100% will ask in annual examination. Compulsory 2 marks question. Compulsory 2 marks question arises only two concepts in the solid state. One is the number of calculating the number of atoms present per unit cell. Simple cubic unit cell, body centered unit cell, face centered and edge centered. And after that, they will ask the questions based upon the calculation of density of crystal lattice. So as well as along with this board examination, for the point of entrance examination they will ask the density, or they will ask the edge length density, or they will ask the molar mass. Now, how many number of atoms present in BCC, FCC or edge center? Clear, students? Okay. So 51.7 gram per mole. 51.7 gram per mole of this crystal BCC element containing how many number of atoms present in 208 gram. So this can be calculating. The calculation 51.7 gram per mole of element having 6.022 into 10 raised to 23 atoms are present. 10 raised to 23 atoms are present. Then 208 gram per mole of element, how much atoms are present? So this is by multiplying, and this is the cross multiplication takes place, or you can take this is the x value. So x is equals to 208 into 6.022 into 10 raised to 23 whole divided by 51.7 whole divided by 51.7. Therefore, the number of atoms is x is equal to 24.1 atoms. 24.1 into 10 raised to 23 atoms are present. 10 raised to 23 atoms are present. So 208 gram of element containing 24.1 into 10 raised to 23 atoms are present. Clear? Now only this calculation is this much of gram element is present, but in this much element how many atoms are calculating? By using the 51.7 gram element having a 6.022 into 10 raised to 23 atoms are present, and 208 gram how much atoms are present? So this value is taken as a x. So x is a cross multiplication, and this is the calculating, divided by 208 into 6.022 into 10 raised to 23 divided by 51.7. Therefore, x is equals to 24.1 into 10 raised to 23 atoms. Clear? The next problem solution. The edge length of a NaCl unit cell is 564 picometer. Edge length A is equal to 564 picometer. So this picometer can be converted into 564 into 10 raised to minus 10 centimeter. Clear? So next one, what is the density of the NaCl? Calculating the density of NaCl. So in the previous problem, the given data, molar mass and the crystal lattice FCC, BCC. So in this one, they don't give any crystal lattices or molar masses. So only thing is the given value is edge length. A value is given. Now we are going to calculate the molar mass. Molar mass of NaCl. So what is the molar mass of NaCl? M is equals to the sodium is 23 plus chlorine is 35.5. What is the total value? So 58.5 gram per mole. 58.5 gram per mole. This is the M value. And the next one, the number of atoms Z value. So Z value for in the previous we are discussing the for ionic compounds. ionic compounds, number of atoms in a unit shell, number of atoms in a unit shell of NaCl, unit shell of a NaCl is Z is equal to 4. Z is equal to 4. Therefore, density D is equal to Z into M whole divided by Na into A cube, whole divided by Na into cube. Therefore, Na value is given. Na is equal to 6.022 into 10 raised to 23 per mole. Substituting all these values, Z value is 4. Molar mass is 58.5 whole divided by Na is 6.022 into 10 raised to 23, and A is into 564 into 10 raised to minus 10 whole cube. 10 raised to minus 10 whole cube. Substituting all these values in this equation, the final answer is 2.16. The final D is equal to 2. Density is equal to 2.16 gram per cm cube. This is the D value. Clear? Very simple. NaCl, the NaCl and cesium chloride. In case of cesium chloride, so the cesium chloride is given value, number of atoms is 1, and in case of NaCl, the number of atoms is 4. So these two are the exceptional cases. So sir, its length is given value 564 in 10 raised to minus 10. The picometer is converted into centimeter. This is very important. Conversion is very important. And NaCl, density NaCl, molar mass of sodium plus molar mass of chlorine. So totally 58.5. Z is equal to ionic compounds. If the ionic compound is NaCl, coordination number is 4. Therefore, substituting D value Zm divided Na into A cube. Na is the Avogadro's number. Avogadro's number is 6.022 into 10 raised to 23. Therefore, 4 into 58.5 whole divided 6.022 into 10 raised to 23. 564 into 10 raised to minus 10 whole raised to cube. So finally, you will get a D is equal to 2.16 gram per cm cube. So based upon this one, we are discussing the problem calculating the density as well as the molar mass or a number of atoms. Z value is also calculating in the previous example. Clear, students? Okay, thank you.